Hello everyone, and thanks for watching Edupedia World Videos. In this video, I will show you the solutions to the physics questions of Paper 2 of JEE Advanced 2015. I will solve the problems as they appear in Code 1. The first problem tells us of a spherical mass capital M and two small masses small m each. The first mass capital M is at a distance r from the first small mass, and they both have a distance L between them. And the only attraction between them, the only interaction, is the gravitational attraction. So the mass capital M will be attracted towards the right by these two, this mass will be attracted towards the left by these two, and this will be attracted both towards the left and towards the right. These two masses are connected by a light rigid rod. And we are given that if R is equal to 3L, then the tension on the rod is 0. And we need to find out a relationship between the two masses. So the first and the easiest step is to draw the free body diagrams. Now I'm not going to draw the individual free body diagrams, I'm just going to draw it within this figure because the only forces are gravitational forces. This has two forces towards the right. This has one force towards the right, one force towards the left. This has two forces towards the left. These are the gravitational forces. Also, this might have one force towards the right or left depending on the tension on the string. But it's given to us that the tension in the rod, and it's given to us that the tension in the rod is 0. Right. Now, since these two are connected by the rod, they both will always have the same acceleration. Right. So, for both of them, MA will have to be the same. That means the net force on these two must be the same, and tension is 0, so the gravitational force on these two must be equal. We know that the force on this is towards the left, so the force on this must also be towards the left, and both of them must have the same value of ma for them to have the same acceleration. So what is the force on this mass due to this mass? That is gmm by r square, but r is 3l, so 9l square. This is towards the left, minus this force towards the right, which will be gm square by l square. This is the net force on this particle towards the left, which will be equal to ma for this particle. The same ma will have to be true for this particle because they are connected by a rod. And for this particle, the forces, both of them acting towards the left, are gmm by r plus l whole squared. R is 3l plus l is 4l, so by 16l squared plus gm squared by l squared. So now all that's left is to simplify this. We get this minus this, that means we get 7 gmm by 16 times 9, that is 160, 144 l squared is equal to 2 gm squared by l squared. And from this we get, if you can cancel other things out, m is equal to 7 by 288 capital M. But we are given in the question that m is equal to k times m by 288. So our answer to this question is k is equal to 7. So let's look at the next question. In this question, we are given the energy as a function of time of a system is a squared e to the power minus alpha t, where alpha is given to us to be 0.2 per second. We are given the percentage error in A as 1.25%. We are given the percentage error in T as 1.5%. So first of all, we can take the log of this, which makes differentiation easier. So it will give us ln E is equal to 2 ln A minus alpha t. Differentiating this will give us dE by E is equal to 2 dA by A minus alpha dt, and there will be no d alpha times t because alpha is a constant. Now this is the equation for the derivatives, but we actually want the errors, and we know that even if two things are subtracted, the errors are the modulus, so they are always added. So mod of dE by E will be 2 times mod of dA by A plus mod of alpha dt. because even in A minus B, the errors are error in A plus error of B, right? So this is dA by A is 2 times 1.25% plus alpha is 0.2 times dt. Now dt by t is 1.5% and we are given that t is 5 seconds. So dt will be 1.5% of 5 seconds. Now this is dE by E, but since we need to find a percentage error, we can just multiply by 100 on both sides, and what we'll get is, this is 2 into 1.25, that is 2.5, plus 0.2 into 5 becomes 1, so it's 1.5, that is 4%. So the answer to this question is 4. Let's look at the next question. In the next question, we are given the densities of two solid spheres which have the same radii, vary with distance in different ways. For one of them, rho A as a function of r is k times r by r. For the other one, rho B as a function of r is k times r by r whole to the power 5. We want to find the ratio of the moment of inertia. So first, let's just write the definition of moment of inertia. For spheres, we can take concentric shells and we can try to find the moment of inertia of one particular shell and we can add them up. So the total moment of inertia for A will be integral of, normally it would be dm times r squared, but we know that for a spherical shell about a diameter, it's actually 2 by 3 times mr squared. So 2 by 3 times r squared times dm. Now what will dm be? Dm will be the small mass of this. So the mass of this will be the volume of this multiplied by the density. The volume of this is 4 pi r squared dr multiplied by the density, which is kr by r, right? So we need to solve this. This comes out to be 8 pi by 3 k integral from 0 to r, those are the limits. So we've taken 8 pi and k out and 3 out, so what is left is r to the power 5 by r, which gives me r to the power 5 is r to the power 6 by 6, and 1 r will cancel, so we'll get 8 pi by 18 k r to the power capital R to the power 5. This is my answer for this one. Now for the second one, all that will be different. If I were to just change it right here, IB, this will be r by r to the power 5. That means instead of this being r to the power 5 by r, this will be r to the power 9 by r to the power 5. So r to the power 9 will give me r to the power 10 by 10, and r to the power 10 by r to the power 5 will be r to the power 5. So in this case it will be 8 pi by 30 k r to the power 5. This is IB. And if you want to find IB by IA in the question, so yeah, we want IB by IA, so that will be this term divided by this term, that will be 18 by 30, which we can cancel and we can see it is 6 by 10. So the answer is n is equal to 6. Let's look at the next question. In the next question, we are given 4 harmonic waves of equal frequencies and equal intensities, and they have phase angle 0, pi by 3, 2 pi by 3 and pi. What is the intensity when they are superposed? So we can just use phasor diagrams. This is the first one, this is the second one, this is the third one, this is the fourth one. Now these two will simply cancel out because they have exactly opposite phases. We just need the resultant of these, and the angle between these, as all these three angles are equal, is actually pi by 3. So the resultant intensity will be the same as the intensity of these two superposed. So for that we know the answer. I is equal to I1 plus I2 plus 2 root I1 I2 cos phi, where phi is the phase difference. In this case it will be I naught plus 2 times I naught times cos of pi by 3. Cos of pi by 3 is half, times half. So this is 3 I naught, and then in the question we are given that this is equal to n I naught. So from this I get the answer that n is equal to 3. Let's look at the next question. This is a question on radioactivity, and we are given that the activity and rate of change of activity are defined as activity A is equal to minus dN by dt, which actually is equal to minus of n naught e to the power minus t by tau, right, where tau is the average lifetime. And in the second case we are given R, which is a new quantity, rate of change of activity. It is defined as minus dA by dt. We are given two radioactive sources P and Q, which have the same activity at t is equal to 0, and the rates of change of activities are Rp and Rq, and we want to find the ratio of them, right? So first of all we can just find R. R is minus dA by dt. That means R is equal to the derivative of n by dt. Derivative of that gives me the double derivative of n with respect to time. So R will come out to be n naught e to the power minus t by tau into minus 1 by tau, right? Now we are given that their activity is the same as t is equal to 0. At t is equal to 0, the activity is minus n naught. So n naught is the same for both of them, and we want the ratio of R at t is equal to 2 tau. So for one of them the average lifetime is tau, the other one the average lifetime is 2 tau. So the equation will be Rp by Rq is equal to minus n naught. For the first one it is tau, so e to the power minus 2 tau by tau, because we want it at time t is equal to 2 tau, divided by into 1 by tau divided by minus n naught into e to the power minus 2 tau by 2 tau into 1 by 2 tau. Minus n naught cancel. This is simply 1 by 2, it will become 2, and this by this will become, if you subtract this, it will become, this is e to the power minus 2, this is e to the power minus 1, so 1 by e. So we get this is equal to 2 by e. We are given this is equal to n by e, so from that we get small n is equal to 2. Let's look at the next question. In the next question we are given a prism, equilateral prism, that means all angles are 60 degrees, and we have a ray of light going in at 60 degrees, and then it is going like this, and we want to find out the relationship of the emergent angle. First thing we are given is n is equal to root 3 and theta is equal to 60. For these two values we want to find the value of d theta by dn. That means we want to find the value of theta with respect to n, and then we can use these two values to calculate it. So first of all, the most important thing to realize is, if this angle is 60, then this angle is 30, right? And if this angle is 60 and n is equal to root 3, for this angle r, we can say sine 60 into 1 is equal to root 3 into sine r, right? And from that we can get that sine 60 is root 3 by 2 is equal to root 3 into sine r, or sine r is 1 by 2, or r is equal to 30 degrees. So this is a very important result. Now this is given to us to be 30 degrees. If this is 30 degrees, that means this is 60 degrees. If this is 60 degrees and this is 60 degrees, that means the figure given to us in the question is slightly misleading. This is actually the angle of minimum deviation, and this ray which is inside the prism is actually parallel. Right. Now this is actually parallel. That makes the problem significantly simpler. So this angle is 30 degrees. We know this angle is 30 degrees, and if you look at this quadrilateral, this main quadrilateral, I extend these two. In that case, this whole angle is 90 degree, this is 90 and this is 60. So this angle becomes 120 degrees. But this plus this is 180. So the sum of these two angles is 60 degrees. So if this is R, this is equal to 60 minus R. Right. So we can write the equation n times, now I'm writing the equation for this case, n times sine of 60 minus R is equal to sine theta. Right. Now in this case we calculated this for the specific value of n is equal to root 3, but what if n were not root 3? Right, because we wanted to calculate for general n and we actually put n is equal to root 3 in the end. So in that case the equation will be sine 60 is equal to n sine R, and from that we get sine R is equal to root 3 by 2n. So sine R is equal to root 3 by 2n, that means cos R is equal to root of 1 minus 3 by 4n square. Right. So now I'm going to rub this thing to the left because it's not really significant. We will just write the equation of sine A minus B and substitute the two values, and we will get a relation between theta and n. That is our initial goal, remember. As soon as we get the relation between theta and n, we can differentiate it and put these two values. So we get the equation n times sine of 60, that is root 3 by 2, cos of R, that is root of 1 minus 3 by 4n square, minus cos of 60, that is 1 by 2 times sine of R, so root 3 by 4n is equal to sine theta. Now I can try to simplify it, but it becomes easier if I differentiate it straight away. So sine theta gives me cos theta d theta by dn, and this is equal to the derivative of this whole thing. So it will have a number of terms. First there will be the derivative of this, so there will be root 3 by 2 times 1 minus 3 by 4n squared minus root 3 by 4n plus, this is the first term, plus we'll have n times root 3 by 2 times 1 minus 3 by 4n squared. So this is to the power half, so half into this to the power minus 1 by 2 into, now the derivative of this, so this is n to the power minus 2, so we'll get minus 2 times n to the power minus 3, minus minus will cancel, so we'll get 2 times 3 by 4n cube plus the derivative of the second term will be, this is minus 1, so root 3 by 4n square. Now I'm not going to simplify this because this is getting a little bit too complicated, but all you need to do is, now we've got d theta by dn, right? So we can put the value of cos theta, cos 60 will be 1 by 2, and we can put the value of n as root 3 in this long equation, and if you put n is equal to root 3, you'll get the value of d theta by dn, and you can try to simplify it at home. I've given you the equation, all you need to do is differentiate this, which I've written here, and the final answer will come out to be d theta by dn is equal to 2. Basically this is half of d theta by dn, so this whole thing on this side, if you put n is equal to root 3, this will come out to be 1, and you'll get d theta by dn is equal to 2. So my final answer in this case is m is equal to 2. This is a slightly lengthy question compared to the others. Thank you.